reflections. For reflections, I'm going to show you something that you probably never have seen from other teachers. It's like, because I developed this method. Okay. So, Daniel On's method. What's that? You use the following simple thing, axis, where you put x here, y there. So far, it doesn't look so foreign. You've seen this a lot, right? Of course, that's what it is. Now, the addition is you're going to put negative x here and negative y here. Because that's the opposite direction of y, right? So if this is y, that will be the negative y direction. If this is x, that will be the negative x direction. Got it? Okay, great. So I have a function y equals to f of x. Let's just say it has some weird graph. I don't know what. Just something like that. Okay. Now I want to reflect this over the y-axis. Okay. I want to replace this graph over the y-axis so that the graph now becomes like that. Okay. You know what? It's probably a little more this way. Okay. The graph goes like that. Okay. I'm a perfectionist. All right. Now, to get that formula, the formula for this, what you do is you use this picture. Okay. And think of it like this. You have the y-axis and you're flipping over the y-axis. That's what reflection means, right? You flip it over. Now, if you do this flip over this way, the y stays. Agreed?
Yes. Agreed.
What happens to x? Where does that go?
Negative.
Negative x. X goes to negative x if you flip it over this way, right? So what you do is you take this function and replace by how? You replace x by negative x. That's the graph. Okay? Super easy, right? Okay, let's do another one. What if I want to take this graph and flip it upside down? So the graph would be like, I'm getting confused now. It's probably this one. Okay, all right. So I want to flip it upside down. What should I do?
Change the y.
Yeah, so this time you look at the same thing. Oh, by the way, this is very simple. You just have to make this. You can make this really small and still use it. So since I'm grading the exam, if I see this on the corner of your exam, I'll be really glad. I'll be happy.
And you points
Huh? Yeah. So you want to make me happy, right? Yeah. So you just draw this so that you can actually use it. Right? Okay. So you have this, and I want to flip it upside down. So y goes where?
Negative y.
Negative y. Right? Good.
Good.
So what you do is you take this and replace the y by negative y, and that's the result. Of course, what you want to do is you have to solve this for y, so really you should be writing y equals to negative f of x. In other words, if you put a minus overall to the graph, what happens? It flips upside down. That's what we just learned. Okay.
Double reflection.
Yeah, what if you do double flip? What does that give you?
Negative.
Flip this way, flip that way. That's like
This
negative
same
x, negative y, right? So what is this thing? Negative y equals to f of negative x.
It's just double negative. Flip.
Unfortunately, this negative cannot come out, so you have to write it like this. It looks very complicated, but this has a name. It's a reflection over the origin. Okay? See, if you had any point in here, what's a reflection over the origin? You draw a straight line through the origin, and you come out at the opposite end. These two lengths should be the same. You can apply this to every point on this graph, and that actually will give you the reflection over the origin. And it turns out that it's exactly same as just reflecting once over the y and then once over the x. And that's what you get. Okay, so the graph of this would be first flip it over the y and then you flip it upside down. So it's gonna be it's like a torture now. What's happening? It's like right, like that. Okay. So that's the graph. Okay. Okay. So far it's not that bad, right? Now it does get bad. It does get bad. Because we're now going to reflect over the diagonal. So again, same picture here. X, y, negative x, negative y. You have this diagonal, and you want to flip it over. So let's try a different graph now. Let's say you have something like that. So let's say this is your y equals to f of x. And what I want to do is I want to draw this diagonal line. 1, 2, 3 points. I'm plotting those 3 points because those are the points that won't move after you flip. See, if a point is on the line that you're trying to flip over, they're going to stay there, right? So those are not going to flip over. The other ones, however, this one will go to the opposite side, this one will go to this side, and that's what's going to happen, all right? Okay. If you flip over the diagonal, what will be the formula for it? If you flip over, where does x go?
Negative.
Do this, right? Okay, where does x go?
Up to the left.
To y. X goes to y if you flip over this way, right? Over the diagonal. If you flip this way, x will go to negative x. But if you're flipping this way, x goes to y, right? Where does y go? X. X and y will be interchanged, right? So you see that the graph of x equals to f of y. In other words, you replace y by x and x by y. The graph that you get is like this. It still passes through these 3 points, but instead of having this here, it'd be like that. Instead of having this there, it'll be like this, and it'll be like this. So that will be the graph after you flip over the y equals to x. All right. Last one, just for completeness, but this last one is not as important as this one because this has some other meaning. It has some important consequences. All right. So the last one is, what if you reflect over the negative diagonal? In other words, the negative, the other diagonal, this one. Where would x go to? Negative y. Y would go to negative x, right? So the formula for this would be y is replaced by negative x, so it's negative x equal to, x would be replaced by negative y, so it's f of negative y. So that's the formula for reflecting over this diagonal. And the resulting is, well, you're trying to reflect over this, so what's going to happen? Let me try to use my imagination. Can't do it. I know this is going to go over there. This point is going to go over there. Yeah, I think it's something like, yeah, this time it happens to be the same thing as that because if you write the actual formula, so I know what kind of function will do this. This is like y equal to x cubed. And if you replace x and y, this one will be like x equal to y cubed because you're replacing y by x and x by y. Over here, what you do is y is replaced by negative x, and x is replaced by negative y. And that's negative x equals to negative y cubed because negative cubed is still negative. These cancel and you end up with the same graph. Okay, so you end up with the same graph. Yeah. But the important thing is if you want to move over the this diagonal, you have to replace y by negative x and x by negative y. So that's how you use this simple.